All right, let's look at the theorem 1. All right, let's say H1 and the H2 are half planes determined by line L. All right, it says that if A is a point on the line L and B is a point in half plane H1, then open ray AB is going to be contained entirely inside H1. Right? So let's prove that. So if you look at the picture here, A is a point on the line and B is in H1, then you can see that the entire open ray, so not including A, so entire open ray is going to sit entirely inside H1. Right? So let's try to prove that. Right, start with the given. So A is a point on the line L and B is a point in H1. So those are the givens. Right? So in order to show that something is a subset of another set is that pick any arbitrary point in the smaller set and show that it actually belongs to the larger set. Right? So we're going to start with 3. Right? So choose any, say, point C in open ray AB. Right, so this is just, I can just say given. Alright, then we want to show that the C is going to be in H1. Right, so I'm going to list all possible cases. Alright, so let's see. Oh, actually, before we do that, I'm gonna say, so since C is sitting in a open ray AB, we know that A, B, and C are definitely collinear. Right, it's sitting on a single line, so collinear. So that just comes from line 3. All right, and then I'm going to list all possible cases. So there are only 3 different places. C could be on the line, C could be in H1, or C could be in H2. So I'm just going to say C is in L, or C is in, I'm going to put H2 first because we want to say it's in H1, and or C is in H1. Right? So those are all possible cases. So all cases. Alright, so let's pick on the first case, 6. Alright, let's assume that C is in the line L. Right, so this is our case 1. Right, and we're trying to get in trouble. Right, C is on the line. So let's see, if you draw a picture, C is going to be sitting right here. Right, so we know that A is on the line and C is on the line, so 7. Right, so if A is on the line, C is on the line, so we know that the L can be determined by A and C. So the line L is really the same thing as line AC. So I'm using the using line number 1, and assumption here, line number 6, along with I1. Alright, then now AC is exactly the same thing as line L, and ABC are collinear, which means that the B must be on the line L, so 8. Right, this implies that B must be on the line L. Right, so this comes from the fact that line number 4, ABC are collinear, and line AC is line L, so number 7. Right, but this is a contradiction because this contradicts line number 2. B has to be in H1. So here is the contradiction. Alright, so we eliminated our first case. So we basically eliminated the first case here. Alright, so let's pick on the second case. 9. Alright, let's assume that C is in H2. Alright, so this is our case number 2. Right? Then I'm going to go up here, so line number 10. Alright, so now the picture looks a little bit different here. So C is actually not going to be on here. So it's going to be actually in H2. So C is going to be out here. Right, that's kind of looks strange. So the ray is going to have to kind of go around and hit C. Right, but what can we say from there? Right, so we know that by H1 part 3, and just in case, let's double check. All right, so here's H1. I'm going to just go up. Right, H1 and part C. It says that if you have a point in H1 and another point in H2, then the borderline will meet the segment AB. Alright, so let's do that. So since B is in H1 and C is in H2, so there must be a point. So in between here and there, right, there must be a point D there, right? So I'm going to just say, alright, so there exists some point D in L such that basically D is between B and C. Alright, so I'm using the fact that the B is in H1, so line number 2, and the assumption, line number 9. And then I'm using H1 part 3 to say that there's going to be a intersection point there. Right? Alright, so this means that since D is in L and also L is in L, so we know that 11 L is same thing as line AD. Right, so I'm just using line number 1 and line number 10 along with I1, right, because 2 points determine a line, right? So if that's the case, and we know that let's see, A, B, C are collinear, and here we know that the B, D, C are also collinear, so we can also say number 2, right, A, B, C are on the same line, B, D, C are on the same line, so they are all on the same line. So A, B, C, and D are collinear. Right, so I'm just combining, let's see, line number 4 and line number 10. Right, they are all collinear, right? But AD determines a line L. Oops, oh, I didn't write it correctly, right? So I meant D here, right? So since AD is a line L, which means that they all are going to be on the line L. So in particular, I'm going to just pick on B, right? So this indicates that the B is going to be on line L, right? So this is just combining line number 11 and line number 12, right? But again, this is a contradiction because B is supposed to be in H1, so contradicts the line number 2. All right, so therefore we could eliminate the second case, right? So the only other case we have is number 14. Right, by rule of elimination, we know that the C is in H1. Right, so this is by rule of elimination, and this was case 3. All right, since this is any arbitrary element in the open ray AB, and we could show that that belongs to H1, which means that the entire open ray AB sits inside H1. So line number 15. Therefore, we can conclude that open ray AB is a subset of H1. So I'm just probably using line 3 and line 14. Alright, that's it. I hope that this was clear.